Go ahead.
I'm just going to test the sharing first.
It'll work.
Did that work?
Yep.
Yeah.
Okay, so now I'll just leave that up, and I will just give you a little introduction. I'll give you kind of a whirlwind tour of what I did since most of you last interacted with me. Hey, John. John and I worked on a national standard called Open Firmware. And I had a company for several years that deployed Open Firmware. It was a Forth-based boot firmware for pretty much any microprocessor on the planet that needed, general purpose operating system. We deployed that on a lot of different systems, including all of the Power PC machines from Apple and IBM and various other companies. And that ran its course and kind of died out when Intel sort of took over the market, ran all the RISC companies out of business, and did their own thing called UEFI, which was basically like Open Firmware, but worse. So after that, I went to work for a company that was making golf video cameras, and I used Forth to build a web-connected high-speed camera that could capture the impact of a golf club and a golf ball. That was during the dot-com era, and when it became the dot-bomb era, that company went down, augured in dramatic fashion. I then went to work for a company that was doing voice recognition for cable TV, so that you could ask your remote control, for channel selection and what was on and things like that. All that's all kind of done deal now, but back then it was a big thing. And I used Forth to, in fact, Open Firmware to do the operating system or do the booting for a massively multi-processor computer that was supposed to do voice recognition. And then that kind of fizzled out, and I went to work for One Laptop Per Child, the so-called $100 laptop that actually came out as $200 because of various factors, not the least of which was that the dollar went south. And I used Open Firmware in that because the boot firmware for this children's laptop was Open Firmware, and that's probably the pinnacle of Open Firmware technical development. We had a dramatically wonderful firmware in that little green laptop, and not only could it do its booting thing, but it had a full manufacturing diagnostic suite and field diagnostic suite, including a visual indication of failed components and full support for the various processes that went in the manufacturing, up to and including multicast operating system updates, so that you could set up one of the laptops as a server and it would broadcast the operating system, and hundreds of other laptops sitting around it could receive that and simultaneously update their operating system over Wi-Fi. So that was fun. And then when that ran its course, I thought that maybe I could retire, and I kind of tried to do that, but then my youngest daughter decided that really she didn't want to finish her degree in mathematical economics, but she wanted to switch to computer science. So I figured, I've got another year of college support, so I have to go back to work. So I went to work for a company that was building a ring that will go on your finger with motion sensing, and the idea was to use this ring, use gestures with this ring to control various devices over Bluetooth. And I use Forth in that to do all of the factory diagnostics and a lot of the product qualification testing. So I got tired of that after a couple of years, and because it was kind of going nowhere. And so I really succeeded in retiring. So now that I'm quote unquote retired, after a couple of months, I was trying to improve my golf game, and I was my Achilles heel of my golf game has always been putting, and so I tried to like practice my way out of that, and I just got worse. And so I started experimenting with putter designs, and I came up with one that was really quite remarkable. And it was so good that I decided that I had to market it. So I started a company to make golf putters. And if I can figure out how to switch the screen sharing, see if I stop this one, and I will share a different one. Here we go. And I'll go to, I think I will go to, oh, this is boring. Well, I'll show you this putter sometime later. Anyway, we'll go back to the post putter activity, which I call hacking farmers markets. And we'll go to this one and share it. Do you see this picture of the farmers market? Yeah. So this is the farmers market that I frequent on Wednesdays, and I started talking to the vendors and getting to know them. And one of the first ones I got to know was Rob and Martha, who do coffee, and they are award-winning coffee producers, having won Best in Hawaii several times. And this cup is a cup of their very expensive but very, very good coffee. And Rob was telling me that he was having trouble hulling the coffee. Hulling is a process where after you remove the outer pulpy material from the coffee cherry and dry it, you have a bean that's covered with a paper-like membrane that has to be removed. And there are big machines costing tens of thousands of dollars that will remove those. But and the people on the island that had such big machines used to contract out hulling services, but then we got infested with this coffee berry borer, and they didn't want to contaminate their machines, so they stopped offering the hulling services. So Rob was trying to hull his coffee using a weed whacker, and he would try to hull the weed whacker and put it down into a 5-gallon bucket and use it to agitate the coffee to knock the hulls off. And that was all kinds of trouble. There was the electric weed whackers were not powerful enough. The gasoline ones were smelly and would sometimes affect the taste of the bean. And the lines would break inside the bucket, and you're trying to hold the weed whacker and hold the bucket at the same time. There was just all kinds of trouble. So I said, well, I can probably make you something. And so I invented this thing. It's a coffee huller made with a skateboard motor, and it uses the hard weed whacker blades sitting in a 5-gallon bucket, and it really does a good job. It does small batches, so it's the perfect size for the gentleman coffee grower, of which there are many in Hawaii. And it turned into a product. It's all built from off-the-shelf parts. The only kind of custom part is this 3D printed adapter from the skateboard motor shaft to these blades, and the rest is made with just basically buckets and plumbing pipe and a little bit of CNC milled stiffeners. So that was fun. And so then I got involved with a friend of mine who has an HVAC company, and I scavenged some old from him and made a motorized coffee pulper. And then he had a problem with his giant press brake. It stopped working. It has a CNC controller, but it's really ancient 1980s tech. And you see, you know, this is stuff you all grew up on. I grew up on. But the factory could no longer support this. They had nobody that understood it. But I mean, this was just kind of right in the middle of the early part of my career. So I could, you know, look inside this and know exactly what was in it. And long story short, it turned out that a plasma torch nearby had sent ionized medical particles through the air that corroded this part on one of the circuit boards, and so I got to fix that and got him back on the air and saved him about $1 million. And then he had the contract to do the climate control for one of these telescopes on the top of Haleakala, but his controls guy quit and went back to the mainland. And so I got to spend a day up inside this telescope fixing his control system. And then I got involved with a kombucha company. So this is a small kombucha producer, and they have you know, they do fairly small batches, and they were doing a whole lot of things manually. And so I've been helping them automate. So let's see, you know, they basically, you know, make kombucha and fill kegs and fill bottles and things like that. Washing system that involves a person manually cycling valves on a fairly tight schedule. So you'll turn on the water valve and rinse the keg, and then you turn it off and you let it drain for a few seconds, and you turn another valve to blow some air in there, and then you turn that off, and then you turn on another valve to put some vinegar through it for a certain period of time, and you turn that off, and then you turn on the fresh water valve and you turn that off and you blow some air in, and then you turn on the hydrogen peroxide valve. And it was just really tedious. And they were hiring woofers, or, you know, young people doing kind of internships to do that. And it would just drive them crazy. And they would make mistakes, and there would be cross-contamination between the hydrogen peroxide and the vinegar when they would make a mistake, and it was just a disaster. So I automated that by using a microprocessor programmed in, guess what, Forth, to cycle these valves and the pumps and various things in the right sequence to automatically wash this keg. And we were going to turn this into a product until he had a family problem, had to sell the company, and the new owners, you know, really like the product, but they're just kind of busy building up their production, and they can't, you know, don't have time to try to market the thing. And then I designed for him a bottle capping machine. He had one that was pneumatic. You have to apply several hundred pounds of force to crimp a bottle cap onto the top of a bottle. And the pneumatic one would often break the bottles if you misaligned the capping bell with the cap. And not only that, it required an air compressor. And if any of you have ever spent any time in an enclosed room with an air compressor, it's really, really exciting when it turns on. So I built one using electricity, and the actuator is a highly geared down linear actuator, which is basically a motor with a gearing system. They're used for hospital bed lifting, and they're used for opening automatic awning windows and various things like that. Not very expensive, but if you get the ones with the right gear ratio, you can apply enough force to crimp a bottle. Much cheaper, much more pleasant to use. You insert the bottle into this frame, and it touches a micro switch, and the thing goes and caps the bottle and comes up. So that was another interesting design. Lately, I'm programming everything in my C4 implementation, which is completely compatible with all of my other implementations that were using assembly language meta compilation. The C4 is really nice because it works with lots of different new processor architectures, including like the various ARM and the ESP32, ESP8266, and so C compilers have gotten good enough that there's hardly any reason to do assembly language anymore. So the farmer's market mantra is that there's a lot of people out there doing stuff that could require small scale automation. And if you get to know them, a lot of opportunities for helping them using your technical skills will immediately appear. So with that as background, I'm going to show you some of the other things that I've been inventing lately. So I will stop this and go back to this Fusion window. I've been using Fusion 360 for a lot of the mechanical aspects of my designs. Here we go. So this is a bottle filler, which is work in progress. This is for the kombucha people. It has a valve for CO2 inlet and a valve for kombucha. Underneath this platform is a load cell weight sensor that's used both to detect when you put a bottle there and also to detect when the bottle is full. There's a stepper motor that drives this linear motion system to raise the bottle into contact with a pipe that goes down into the bottle. So you put the bottle on this platform, the weight sensor detects the presence, lifts this into contact with a filling straw, and then does a purge cycle where it injects some CO2 to blow the air out, and then does a fill cycle with the product while applying back pressure. Not shown in this model is another stepper motor that controls a pressure relief valve to relieve the back pressure to prevent foaming. And there's a pressure sensor attached to that as well. So it's all automated. And you put the bottle on the shelf and it lifts it, fills it to a desired level of product weight, and then drops it back down. This is not quite finished. I'll actually show you the finished mechanicals, but I haven't quite dialed in all the process parameters. Oh, here's my putter. Yeah, there it is. So this is a putter that is made out of bamboo. The material is, I can either use bamboo flooring or I can use bamboo butcher block material, and it's perfectly balanced. This little target thing is the center of mass of the system. The shaft goes right through the center of mass so that there's no torque around your hands. And it's I have a laser engraver that I use to do the logo, and this brass weight creates the right total mass of the putter head while preserving the center of mass relative to the shaft insertion position. I've made several hundred of these, and orders during COVID were very low, but now they're picking up, so I'm going crazy trying to keep up with production. One of the interesting problems in producing this is that this shaft lean angle is something that's fittable to different golfers. So in order to preserve the aspect of the shaft going through the center of mass, you have to figure out exactly where to drill this hole and at what angle. And that can be kind of tricky. So I invented this drilling fixture. This mechanism clamps onto the bottom of a drill press. And by rotating this table around the screw axis, you can set the basic tilt angle. And by rotating this turntable, you can set the forward angle. The putter head sits inside this holder. And once you set the two angles, the drill bit will go directly through the center mass of the putter. So that's a very low cost way of getting accurate drilling. And I have several distributors in various countries that have copies of this so they can set up their own drilling fixture so they can fit their customers and do a custom drill right on the spot. Let's see what else. Oh, here's another thing that I did for the kombucha people. This is a very simple thing where they have to, they're trying to fill the, they're filling buckets from a keg of partially brewed product, and they need to use this chugger pump to fill this, but then to top it off, they top it off from this pressure, or this tank that's up above. And that was another one of these processes where it was taking them just too much time. There's too much detailed supervision, and by automating this with a microprocessor, instead of spending 3 or 4 minutes where you're just you're a real-time control system, you can be talking on the phone or whatever, and then you press a button and it goes. So I've done a few of these real simple kind of filling devices for them. Let's see. Lately, I've been working on, let's see if we can find this other window. I'm going to stop this one and find the other one. And it is, okay, I got involved in a lot of CNC work, DIY CNC, and there is a guy named Bart who has been doing CNC, low-cost CNC controllers based on the open source Gerbil firmware. He did a port of Gerbil to ESP32 so you can control it over Wi-Fi. And the microprocessor, let me just, I didn't, that shared? You see the CNC controller? Yeah. Okay, so this microprocessor, the ESP32 microprocessor, doesn't quite have enough GPIOs to control a multi-axis system. So he was always having to do new board variants for different kinds of usage scenarios, or different numbers of axes, or different spindle controls and stuff like that. And I helped him develop a hardware expansion solution that can expand the IO controller, the IO system, with very, very high speed, low latency, low jitter IO. And so based on that, we co-developed this new controller that can have up to 6 axes with on-board drivers, and with off-board drivers, you could go up to 12 axes if you know what to do with them. Plus, it has modular input and output boards so that you can just plug and chug different kinds of sensing devices, or different kinds of spindle controllers like lasers or plasma torches or VFD motor controllers or PWM spindle controllers, you know, you name it. It's expandable with these just plug-in modules, but super flexible. And there's actually a little bit of fourthiness in this, in that in order to support this height expandability, I re-architected the configuration system for this firmware based upon fourth words. And what I mean by that is I created a C++ class that is called Word, and it's the basis for a name equals value configuration system that blew right through the limitations of Goebbels' numbered parameter configuration system. And with that highly flexible name equals value configuration system, we were able to add hundreds of new configuration variables that are able to support this very wide variety of new I/O capabilities. So we're having fun with this, and we're going to make it fully runtime configurable in the near future so that users don't have to recompile at all. They just get one version of the firmware and then load a markup file into it that will fully configure it. So let's see, I'll unshare that and show you what I've been working on in the last 2 weeks. So due to COVID, my daughters started moving back home, and we didn't really have space for them all. So we had this farm structure that was basically an open frame shed with a corrugated roof, and we had used it for various things like a workshop for, you know, fixing the mowers and stuff, or it was a dog kennel for a while, and it was a junk storage area for a while. And so we're building it out as an apartment for my daughter, one of my daughters. And this is the SketchUp design for it. I have a friend who's a builder. He had some time between jobs, and so he came over, and over the last 10 days we've turned this thing from a kennel into an apartment. And, we're pretty close to finishing that. But one interesting design thing is, you see this Murphy bed here. I didn't like the Murphy bed mechanism. They cost about $300, and they're kind of goofy with springs and stuff like that. So I designed a better Murphy bed, and I'll show you the design for that. Let's stop the share here and go back to Fusion if I can find it. Fusion, share screen, there, share, where is it? Oh. I'm going to have to go back to a different thing here. Wow, I can't find it. Okay, I'm just going to describe it. So instead of having a mechanical arrangement of springs to counterweight the bed so that you can, you know, lift a heavy bed, I realized that if you put big discs on the side of the bed near the place where it tilts up, you could just roll the thing up on the discs, but you've got a problem that it's too heavy. So I realized that you could attach bricks to the back of the bed to move the center of mass of the whole system closer to the rolling point. And with about 100 pounds worth of bricks, which is something like about $30 worth of bricks, you could move the center of mass close enough to the rolling point that the effective weight at the leverage point where you're lifting is about 15 pounds. So I'm looking forward to building a tilt-up Murphy bed with no moving parts for the apartment. So that's a synopsis of the kind of stuff that I've been working on. Last thing I'll do is I'll just show you some of the physical artifacts here. So this is the CNC controller, one of them. This is the, it's hard to see this, but this is the keg of the bottle filler. You can't really see it. Oh, let's see if I can put something behind there. Yeah, there we go. Yeah, so this is the bottle filling machine. There is a keg that would be full of kombucha, but it's actually full of water just for testing. There's a CO2. Where is it? There's a CO2 cylinder. And oh, here's an interesting thing. With my coffee huller, I have this power supply that drives the motor. And I was getting these from China for like $10. And then all of a sudden it stopped working. The power supply did not have enough power to drive the motor. And what I found out was that this model JDT001, which I had been using, had been switched out to this model KLY. And they have identical specifications at maximum of 25 volts at 3 amps, but they behave very, very differently. And so I did, some VI curve calculate or measurements and found that the JDT001 model that I had been getting had very, very different overload characteristics. When you try to drive more current than the rating on the JDT001, it just drops the voltage but continues to pump out current. So it's almost a constant power overload characteristic. And it's very, very good for motors because when they're starting, they need a lot more current, and under load, they need a lot more current. Whereas the new one is very, very hard current limit at 3 amps, regardless of the voltage. So when the motor starts to want more current, especially during starting, it just won't supply it. And so this the new model just doesn't work. And I'm not sure I can get the old model anymore. I haven't been able to find a source. So we'd have to redesign the power supply architecture. So that's kind of all I have to say. Does anybody want to ask any questions?
Yes. You mentioned using ESP32 to communicate with this board for controlling a CNC system.
Yes.
I'm presuming you download the G code to the board and then run it from this control board, so you don't have any latency problem, because with the wireless you can't be assured that you're going to get your data flow going at full speed all the time.
So there's a couple of different solutions. The traditional way of doing this Gerbil controller is that it has a serial interface, and the serial interface feeds G code into a queue, and the controller pre-processes the G code into a motion plan, and hopefully the serial interface is keeping the queue full so that you don't have any stuttering. And in general, that's the case because under most scenarios, the serial is way faster than the motion. Typically a motion segment will be many milliseconds long, whereas it takes less than a millisecond to send a line of G code. So that's the serial scenario. The Wi-Fi scenario is even better. You could send G code over Wi-Fi and stay ahead of the motion quite easily. But in this particular controller, we also have an SD card. So you can just upload the G code program to a file on the SD card, and the controller will process the G code from that file. And over the wireless interface, you just tell it, to run the file, and the wireless will collect telemetry and show you the progress. I don't hear you. I don't hear
needs
you.
to unmute. He's muted.
Okay. You'd have a problem with machine shop where you've got all this machinery that really isn't electrically friendly. And so I would hate to use a system in a real machine shop like that and trust the Wi-Fi.
Yes. We also have problems with interference from spindles. So one of the things we've done with this controller board is what we call a Bulletproof Io that's optically isolated every 6 ways from Sunday. I would not recommend using this in a production machine shop. Yeah, for no other reason that there's the hardening problem, as you say, but there's also latency issues that are very difficult to solve with the separate controller and separate display. And I think, for production use and on a big machine, you really want to have very tight integration of everything for no other reason than for safety.
I was curious about various, let's say, there's a longevity problem of softwares. Technologies changed. You won't be able to get those little microprocessors anymore, stuff like that. What do you give the customer so that they have a way of dealing with the future of the machine?
Well, first of all, only a very small number of these are products. The coffee huller is a product, but I'm really only dealing with the boutique market. So now I have a very small number of customers, and I just give them good service. So when the thing breaks down, a lot of them are local, so I just go pick it up and fix it and take it back. And in order to keep myself sane, I'm mostly doing non-mission critical stuff. So if it breaks down, well, instead of buying the $300 thing from me, they're going to have to go buy a $10,000 thing from a reputable supplier. And thank you very much. No, the kombucha customer basically, I just trade automation for kombucha. So in order to keep myself, enjoying this, I'm not doing too much customer service. If you want it, good. If you don't want it, well, see you later. And I don't have anything against customer service, but that's real work, and I'm retired. I'm having fun.
Let's make that the last question and move the show on. I'm reminded with your comment about customer service as to why Fourth Incorporated's prices were always so high. They said, gee, if we have to support this, we'll have to charge money enough to pay the support guy. And unfortunately, other companies like, for example, well, let's not cite any examples. Other companies decided, well, we're going to publish software and charge what we charge for it, not support it. And it's much cheaper.
Yeah.
All right. On that cheerful note, thank you so much, Mitch. I guess everybody can click their thumbs up button or their wave or, thanks or twinkle. Yes, let's all twinkle.